This is a 2-minute question. In the exam, you should recognize it, answer it, and move on to something hard. Today's CKA task: give an existing web server container a named port. Then expose it with a service that is reachable both inside the cluster and on the nodes themselves. It is 3 deliverables, and one of them is a single command. Here is the setup. A deployment called catalog is already running in the storefront namespace, and its container, web server, declares no ports at all. 3 things are asked of you. Give that container a port entry. Name it web, port 80, protocol TCP. Put a service called catalog-svc in front of the deployment, and have it target that named port rather than a raw number. And make the service answer on each node's own address as well as inside the cluster, which is a decision about the service type. 1 edit, 1 service, and the right type. Before we touch anything, understand what a containerPort is, because that is what this task is really testing. Declaring a containerPort does not open a port. Nginx already listens on 80, whether or not the pod spec mentions it, and nothing blocks traffic to an undeclared port. What the entry gives you is documentation and, more importantly, a name. A service's target port can then say web instead of 80, so the backend port can move without editing the service. That is the chain. The service has its own port, its target port points at the container's named port, and if the service type is NodePort, the API server also allocates a port between 30,000 and 32,667 that is opened on every node in the cluster. Start by reading what you are handed. In the storefront namespace, there is 1 deployment, catalog, with 3 pods running, and no service at all. Now read the pod template. The container is named web server, not Nginx, which is a good habit to build. Read the container name out of the template, instead of assuming it matches the image. And there is no ports block anywhere in it. The pods serve traffic fine right now, because the container listens on 80 regardless. What is missing is the declaration, and specifically the name the service will need. Part 1. Edit the deployment in place with kubectl edit deployment, catalog in the storefront namespace. Find the container named web server and add a ports block underneath it. Name web, containerPort 80, protocol TCP. Copy the shape from the Kubernetes docs if you want. The service page has it. But watch the indentation. Ports belongs to the container, at the same level as name and image, not to the pod spec. Write and quit, and kubectl pushes the change straight back to the API server. Changing the pod template triggers a rolling update, so the deployment replaces all 3 pods. Wait for rollout status to say successfully rolled out, because a half-finished rollout is how you end up verifying against a pod that does not have your change. Then read the field back. The container now carries containerPort 80, name web, protocol TCP. Part 1 is graded on exactly that. Parts 2 and 3 are 1 command. kubectl expose deployment catalog. Name it catalog-svc. Port 80, target port web, protocol TCP. Type NodePort. Every part of the task maps onto a flag. Target port web is the payoff for part 1, since we can now reference the port by name. And expose copies the selector from the deployment for you, which matters more than it sounds. A handwritten service with a selector that does not match the pod labels is the classic way to end up with a service that has no endpoints and answers nothing. Look at the result. Type NodePort, port 80, and the API server allocated a NodePort from the 3000 range. Describe the service and check the 3 lines a grader would check. Target port reads web, not a number, which proves the service is following the name we added. NodePort shows the allocated port, and it is open on every node in the cluster, not just the one the pods happen to run on. And endpoints lists all 3 pod IPs on port 80, which means the selector matched. An empty endpoints line is the failure mode to look for. The service exists, it answers nothing, and the task is marked wrong. Now prove it carries traffic, both ways. First, through the ClusterIP, by name, catalog-svc.storefront resolves through cluster DNS and Nginx answers. Then, through the NodePort, using the node's own IP and the allocated port, which is the part deliverable 3 was really about. Same welcome page, a completely different path through the stack. One note on the lab. These curls run from a small pod inside the cluster, because on kind, the node addresses are not routable from the laptop. On a real exam node, you would curl the node IP and port directly from your terminal. A few things to carry into the exam. Ports goes inside the container, not the pod spec, and the wrong indentation is the #1 way to lose this one. The port name matters. If the task names the port web, then targetPort has to say web. Use kubectl expose instead of writing YAML. It is faster, and it gets the selector right by construction. If you do write YAML, the selector must match the pod labels, and remember, it is the pod template labels, not the deployment's own name. NodePort does not replace the ClusterIP, it adds to it, so nothing else has to change. And do not set a NodePort value yourself, unless a specific one is asked for, since letting the API server allocate is both faster and less likely to collide. To recap, we edited the existing deployment and gave the web server container a port named web on 80 over TCP, waited for the rolling update, then exposed it in one command as catalog-svc, a NodePort service on port 80, whose targetPort references that name. We verified the way a grader would, with targetPort reading web, a NodePort allocated, and 3 endpoints behind the selector, then proved both paths with a real curl. Declaring a containerPort does not open anything. It names something, and naming it is what lets the service point at it. Subscribe for the rest of the CKA series, and the full write-up is on dev.to.